Good evening, everyone. Am I audible?
Yes, ma'am.
Okay. Okay, so today is the first revision session for quiz one. So there will be two revision sessions, one today, one tomorrow, I think. Yeah. So today's session we are going to discuss PYQs from all 4 weeks. So I have a PDF of questions. We'll go through them. Let me share my screen once. And then after today's class, in tomorrow's class, you can just discuss whatever doubts you have. But today is just for revision. Okay. Can you see my screen?
Yes, ma'am.
Alright, so I have about 30 questions here. All are PYQs from previous 3-4 years. And these are all the important questions, and some of them have been repeated also. So if you go through all these questions at least once before your exam, you should be able to score good. So I will discuss all of the questions one by one, and then at the end of the session, if you want, you can ask me. I'll share the PDF with you. Okay. So the first question is from week 1. What is the lowest level of data abstraction? So what's the answer for this?
Physical skill.
Physical level.
Physical level. So what happens in physical level? What type of data is stored in physical level? Anyone can tell me what is the type of data that is stored in physical level?
Skeletal system of the data schema.
So schema has 3 levels, right? Physical, logical, view. So view is the outermost level. That is the level that the user can see or interact with. Logical level is usually what we say relationships between different relations. What does physical level store?
It is the actual data structure in which the tables are stored, like how bits and bytes are arranged.
Correct. So physical level is the information about how the data is actually stored in memory, right? And that is the lowest
Pure
level
form
of
of data, ma'am.
abstraction.
Can we say that?
Yes. So, for example, all of this data, it is stored where? It is in your secondary memory, like your hard disk, right? So in later weeks, we will see how that data is actually stored in hard disk using different data structures. All this information is in physical level. Okay, so that question is for 1 mark. Now this one. Suppose a company wants to determine whether the price of the commodity will be an attribute in the shopping database or not. So price, whether it should be an attribute in a shopping database or not. So which of the following holds good about this? That is, which of these statements is true?
Logical level.
Logical level.
Logical level.
So this is a logical level decision. Why? Because it is about manipulating the relation
Business
itself,
logic.
right? So whether you want to add some new attributes, delete some attributes, all of these are logical level decisions. Okay, this is for 2 points. Now this one is from week 2. So the number of tuples in, what is this symbol? Left outer
Natural
join.
join. Oh, so
This,
left.
this is left outer join, right? This is the bow tie itself is natural join. Then when you extend it from here, this is a left outer join. So number of tuples in R left outer join S. So this is table R, table S. First tell me if I do left outer join. So how many rows are there in R?
4.
4.
Okay, how many rows in S? Again 4. So how do I do left outer join? Anybody knows?
Cross multiply.
Common attribute between R and S and the left attributes of R.
Okay, so how many common attributes are there between R and S?
2.
Then how will we do the matching? You have to solve. Just give me 1 second now. I'll reshare just a second. Okay. Yeah, tell me how to do this, how to solve.
So there are two. First we match B and C from R and S. So first the last second row matches with the first row. So
First of all, tell me, am I going to take B and C together or not when I do the matching?
Yes, ma'am.
I have to
Yes,
take B
ma'am.
and C together because these are both common attributes, right?
Yes, ma'am.
So let's take each of the combinations. So first combination of B and C I can see is 2 and 3. Can you find a match for 2 and 3 in S table?
Yes,
Second
ma'am.
row
second,
and
Second
fourth.
row is two.
So
Second
And fourth.
last two.
let's number the rows. So this is row 1, 2, 3, 4. Let's call this row 5, 6, 7, 8. So row 1 B and C combination matches with row 6
6 and 8.
And 8.
row 8. Fine. Then for row 2, this 4, 6 combination, is there a match?
No,
Uh,
ma'am.
no ma'am.
No. Fine. For this one, 7, 3,
No, ma'am.
Yes,
there
yes
is
ma'am.
Yes,
first
there is
line.
a match.
Fifth line.
So row 3 matches with row 5. Okay, we found one more match. Now last row 4, there is no match.
No.
Okay, so how many matches did we find? 3 matches.
3.
Which one is the left table? R is the left table. S is the right table. So we found 3 matches, and in left outer join, what we do? We take the matched rows and whatever is left in the left hand side table. So which row is left? How many rows are left in the left hand side table that did not find any
Second
match?
and fourth.
Second and fourth
And
rows.
fourth.
So we have 3 matched rows and 2 unmatched rows from left hand side table. So total how many rows will be there in left outer join?
5.
5.
3 plus 2, 5. So option C is correct. This is clear for everyone?
Yes ma'am.
Similarly, you can do for right outer join. So if I just change this symbol to this. So let's do that
And it
also.
will ask for full.
Full means what? You will take the matching ones, the left, the whatever is unmatched from the left table and whatever is unmatched from the right table. Right.
Left.
What do we do for the unmatched rows that didn't match? We put null value in the other columns, right?
Yes.
So let's do the same problem for right outer join once. Now tell me, this S is the right table, right? So how many matches are we finding? 3 matches
One
will
match
be
for
there.
7, 3 and 1 for 2 and 2 for 2, 3.
Matches will be 3 only, right? Between these two tables, matched rows are 3 only. Okay. So wait.
Again to one match table.
So here, when I do right outer join, 7, 3, is it matching with any of the left? Let me write the thing properly. 7, 3, this row 5, does it match with any of the rows in our table?
Yes, yes. Third one.
Yes, third one.
5 matches with 3. Okay. Then row 6, 2, 3.
6
Does
matches with
Two.
2.
Matches 1.
Sorry.
okay, matches
1.
with 1. So 6 matches with 1. Then row 7, 3, 7, does it match?
No.
No.
Third.
For row 7,
No.
no match. And row 8,
Matches
1.
with 1.
Matches with first.
matches with the first one. So how many rows will be there in the right outer join totally?
4.
4 rows, ma'am.
4 rows, right? 3 matched rows and this 7th row is unmatched. So it will take null values in place of this A attribute, right? Okay.
Ma'am, what will be the maximum number of rows possible in left outer join or right outer join? So if in this case, can we say like maximum rows will be
Maximum will happen when, when this, let's say one of the rows matches with all other rows in the other table. Okay.
okay?
If I am doing left outer join, then if this 2, 3, let's say matches with all these BC combinations are, if it is 2, 3 for all the rows, okay, then it will match with all 4 rows, correct? And
Okay.
it also has 3 rows of its own. So that's the maximum case.
So 7 will be the maximum, right?
Mm-hmm.
Okay.
All right. Now this one. Consider the relation schema company. It has 3 attributes: name, area, and city. And project has 3 attributes: PID, that is project ID, budget, and location. So the domain of attributes city and location is the same, right? That is Indian cities. So they have the same domain. Which of the following relational algebra expressions would list all cities that are common in company and project? So we want list of cities that are common in these two, right? And these two attributes have the same domain. So obviously you have to work with these two attributes only. So now you have to identify the relational algebra expression. Let's start with the first one.
Option C,
Yeah.
ma'am.
Option C. Okay, I'll see which one is
Fourth
correct.
option.
Okay. Let's go one by one and we'll decode. Okay. I also don't know. So if I take the first option and check, so pi of city from company, that means what is this operation pi?
Project.
Projection.
Project.
Projection does what?
Selection.
Remove all
Selecting
tables.
column.
Projection will project an entire
Selecting columns.
column.
Yes,
Right.
ma'am.
So city is projected and location is projected. We're taking union. What does union do? It will take, if this is the city
All
set
the
and this is the location set, right? If let's say they intersect at some level, so it will take the entire thing. That I don't want. I just want the intersection. What is list all cities that are common? So this is wrong. Again, if I just subtract it, that means this whole thing is gone. So I am getting this part. This is not the common. So second is also wrong. Third, if I do natural join, what does natural join do between two columns?
It
Can
would
you,
match
first of all,
the
can you do natural join?
no, I think
no. Okay. City and location spelling are not same. That's why, ma'am. Can we say that?
The attributes are different, correct? Natural join doesn't know that whether the domain is same or not. It looks at what the attribute name. These are different attributes. I cannot perform a natural
ma'am,
join.
sorry to interrupt you in one of the activity question I have activity or graded assignment. I think natural join is performed between two tables which have different name attributes have different names. It was
Nothing is
one
in common.
just means the entities are common like for example this city and location like city and location table name is column name is different but the values inside it are same.
No, the column name has to be same for natural join. That's how it identifies the common attributes.
In the graded assignment it was marked as correct like
Can you tell me which question it is?
uh, wait wait a minute ma'am.
Okay, fine. 1 second. Let me check also. But natural join, by definition, it is that it will join two tables based on the columns that share the same name, right? Data
Yes
type
ma'am.
also has to be compatible, but column name has to be same.
Yeah, I told the TA also but he said that it works like that.
You give me the question once, I will check
Ma'am,
it. Okay.
in natural join, the output will the duplicate columns be present
No,
or
no, no, no. Only one column.
okay?
Duplicate columns are there in inner join and cross join.
Okay.
Okay, but in any case, here we cannot perform a natural join. So this option will be wrong. So only the fourth option is left. Obviously, it is correct, but let's see why. So this will project the city attribute from company. So what is this doing is basically an intersection, right? Intersection with set
Yes, ma'am.
difference. So you are projecting everything from city and then everything from column. So if you take out what is common between these two. So first, this is the city set, this is the location set. So I'm taking out the common ones. That is, this entire part is taken out, right? So the common ones are also gone. So now I'm left with whatever is unique to the city attribute, just this part. Now, if you take out this part from the original city attribute, then you will be left with what? The intersection, this part. So this is one way of writing intersection only in the form of set difference. So option D is correct.
Ma'am, it was from activity 2.4, question number 6.
Activity 2.4. Okay, let me
Question number
open that
6.
once. Sometimes activity questions are wrong in a few of the weeks. Let me check. Two point six.
2.4, question number 6.
2.4 question 6.
Select star from student natural join department.
Just a second. So how many rows will be fetched as a result of the following query? Select star from student natural join department. No, here 0 should be the answer. Nothing is in common.
But 0 is incorrect. The 10 is marked as the correct answer.
10.
Yeah.
Okay, so
This
they
will
have taken
will
the
be
stream
Cartesian
and
product.
But the question says
10
natural
will
join.
be if it's a Cartesian product. This one, the answer should be 0. I think there is some kind of a mistake here. Because stream and department, even though they have the same domain, but they are not the same attribute. So natural join is not possible here. Okay, I'll tell the team to remove this question from next term. But it is not graded, so it's fine. But no, this is not correct. Okay. Always natural join, you have to check the attribute name.
Okay, ma'am.
Okay. This, yeah.
This last option,
Hmm.
this company,
Yes.
the city is projected. The
Hmm.
city is chosen. Column city is of the company is chosen,
Hmm.
and from the project location is chosen.
Yeah.
So
First,
is
let's
it set
first do this
difference?
part. This the entire thing is set difference. Okay, but first we'll do the inner set difference. This part. Okay. So first you project everything from the city set, and then you take out whatever is there in common with the location set. That means just subtract location from city. So this entire part will be gone, right? So what
No,
is left?
but before subtracting, by projections we are selecting projecting means we are choosing one column, right?
Yeah, on the attribute. Yes.
So that will be a city column.
Yes, that's the city column values. The set of values from that city column.
Yes, and from the project, it is a location.
Yes.
So both the things will be same.
Yeah,
Like location
because
will be Delhi
see,
and city will be Delhi.
set difference. What are the conditions that they have to be from the same domain? Right. That's
Okay,
the
but the domain of location and city will both be the same, right?
yeah. It is mentioned in the question. Domain of attributes, city and location is same.
Okay.
Okay, so this part of the city is left, city attribute is left. So if you take out this part from the original city attribute, you will be left with the intersection, this part. Okay, this is clear for everyone?
Yes, ma'am.
Okay. See, here in the solution also it is written that 0 rows are returned, right? Because these are different names. Okay, this question, wait, I'll increase the font. You can read it?
Yes, ma'am.
So we have to consider a relation called G20, which takes attributes, country name, foreign minister name, events, date, venue. Questions, there are 3 questions and there are all of these other options that you have to match with. Okay. So first question is saying find the name of foreign ministers whose names start with small j and have at least 5 characters. So let's do one by one. First one, I want foreign ministers whose names start with j have at least 5 characters. So at least 5, let's check option A. So select foreign minister name from G20 where foreign minister name like j and then there are 4 dashes. So is this at least or exactly?
Exactly.
Exactly 5. So this is wrong. Second one, same thing, but starts with J. There are 4 dashes. That means at least 5 letters will be there, and then there can be more letters or percentage. This is at least, right?
Yes, ma'am.
So 1 will match with B. Okay. Now, second question, find out the number of events taking place in venue gift city. So number of events, that means we have to use aggregation function count. So C, option C. Select count events from G20 where venue is gift city. Is this correct?
No.
No, ma'am.
Ma'am, why first one A is not there because it is asking that name
We need,
start with J and at least 5 characters should be there. So
yeah,
J plus 4 are there, na? 5 characters.
yeah, but that is exactly 5. It says at least 5, means there can be more than 5 also. So we need the wildcard character, that is the percentage.
Okay.
Right, okay. Now,
2C is also correct, right?
C should not be correct, ma'am. When we are using aggregate functions, we need to use group by, right?
Right.
It's not required,
C.
I guess.
The thing is, why C is not correct is because if you just show a count here, okay, why we don't do that? Why we don't just use aggregation functions like count on their own? Is because then the data will not be very much of a sensible data. It won't make a lot of sense to just see a random count, right? See, both of these C and D will give the same and required output. Both are correct in this case. Fine. Output wise, both C and D will give the required output only because we are only asking about the count. But I am telling you this, that if you are coding in SQL, always try to use the group by along with the count, okay, because that is more meaningful data. But in this question wise, both are fine. You can have any. C and
Ma'am,
D.
as per exam point of view, I'm asking if should we choose both options?
That depends on the options that are already given. Okay, so there are 4 options given. This is a MCQ.
Like MS, like multiple select are there. Like here, it's match the following is there or here. Then
Here
what
it
should
is
we do?
also MSQ. See, I will show you in this question only. So till now we found out 1B is correct. So we can directly eliminate option A and option C, right? So 2 and 4.
Yes, ma'am.
Now,
I know we can do like this way. Sometimes we'll get like multiple select. They'll not give this kind of options, right? Like they'll
no,
they'll
if
give.
you get such a question where you see that there is only one correct option given, like here in case of this, if I had 1B, then let's say 2C, 2B or something, and then 3E, then that is directly eliminated. But if you have both the options, then you choose both. Okay, because both are correct. You cannot say that eliminate any one of those because both are giving the correct output. In this case, see 1B, 2C, 1B, 2D. Both these combinations are correct. But we have to do the third one also. This particular question, there is no need to do the third one because you can already tell the answer from eliminating these 2. But still, let's do it. So find out the venue name and number of events taking place in each venue. So here they are specifically asking you that I want the venue name. That means you have to group by venue name. But in the previous one, they didn't ask you to use group by, right? It is a good practice to use group by along with aggregation functions, but it's not required or mandatory. So if you have to find out venue name, number of events taking place at each venue, let's say option E. Select venue, count events from G20, group by venue. This is obviously the correct one. This one will also give an output which is the count of events from each venue, but it is not listed by venue name. So that's why this is wrong.
Ma'am, so we can use the aggregation function. In the aggregation functions, we can use the where clause, or having is necessary.
It is all depending on the question. If you see that it is directly mentioned in the question that you have to group by something like some other attribute like venue name in this case, then you do it. Otherwise, there is no need. Like that is exactly why this question is given, to show you that for question 2 both C and D are correct. Okay, but for question 3 only E is correct. So the correct combinations are 1B, 2C, 3E and 1B, 2D, 3E. So option B,
Ma'am,
option
why sixth
2 and
option is wrong here?
which one is wrong?
Sixth option, why wrong?
What is given? Find out the venue name and number of events taking place in each venue. That means it should be like this. The venue name should be listed like this, and alongside each venue name there should be the count. But in sixth option, select venue, count events from G20, but you're not grouping by the venue name, right? If you're going to use some other attribute in the select statement alongside an aggregation function, that attribute must reflect where in the group by clause. Right, otherwise it's a wrong
Like
prediction.
if we are grouping with,
Yeah, you have to group with the venue, right? Because that's what asks in the question, that you have to group by for every venue what is the count correspondingly. Also, if you have an aggregation function in the select statement and also some other attribute is present in the select statement, then that attribute must reflect where in the group by clause. Okay, otherwise it's wrong. That's why option C is correct here. Why? Because you don't have anything else in the select statement. Okay.
like we are not grouping like fifth option.
No. See, why C and D are correct output wise? Can you tell me? What will be the output? How will it look like?
C and D both are correct because both are giving the gift city means count of the event at gift city. But if someone is asking if we need the at which gift city, how many counts, how many events are happened, then only D is correct. C is not correct.
But again, in D, see, we have given what? Group by venue. But is venue present in the select statement?
No.
That's why the outputs are exactly the same. Okay. They will only show the count in both
Okay,
options.
understood. Okay, now I understood. Yeah.
But if I added venue here, then it would be a different one. Okay.
So, ma'am, whenever we add the attribute in the select option, then we have to use the having
Yeah.
and group by.
If you have an aggregation function in the select statement and alongside that function you have another attribute which you're adding in select statement, then that must appear in the group by clause. Okay. This is important for your OP also. Okay, let's do this one. This is very easy. So you have two tables, R and S. Let X be the number of columns and Y be the number of rows of R natural join S. What is the value of X plus Y? So here, can I perform natural join?
Yes, ma'am.
Because the name of the attributes are same. But now let's see. What is X? Number of columns. So if I do natural join, how many columns will be there in the resultant table?
3.
3, ma'am.
4.
3.
4, right?
Why 4?
Because natural join is like B is not equal, right, ma'am?
Does the compiler know that? Compiler is only looking at the name of the attributes first.
Okay.
See, that's why I said natural join will always first start with matching the attribute names. Here it will first start with matching that, okay, ABC is here, ABC is there. So we can start the process of natural join, and in the resultant table, it will form the schema of the resultant table also as ABC because these are the common attributes, right? No other attributes are there in any of the two tables, so ABC will be there in the resultant table. That's the structure. Now when I start the process, so now I will join all three attributes together and find the combination, right? So ABC together here 0 9 0 0 cat 0, but in this case natural join will not give any rows in results. Why? Because the domain of D is different, right? Since this one comes from integer domain, this one is strings, that means these two will never have a match. So if any of the attributes do not match on all the rows, that means natural join will return how many rows in the result?
0.
So x is 3, but y is 0.
Okay,
X
it would
plus y
return
is
empty table with
empty table.
attributes. Okay, got it
Yes,
now.
no rows. Okay. Okay, this is a very important question. So consider the following table which has 4 attributes A, B, C, D. A is the primary key. C is the foreign key referencing A. That means this is a foreign key present inside a table which is referencing this table only. So this is the reference table, this is the referencing table, right? So a foreign key can be present in a table itself, which is referencing some other attribute in this exact same table. So here C is the foreign key referencing A. Now how many tuples will be left in the table if the tuple 1156 is deleted and on delete cascade construct is applied over the table? Look very carefully. 1156. This row is deleted. Where is this row present? Here.
First row.
First row. So C is referencing A. Now from A is the primary key where all the values are unique. Now from A, which value is deleted?
1.
6 and
1
7.
is deleted.
After that, 6 and 7, right?
Yeah, we'll go step by step. See, 1 is deleted. Okay. So now can C be referencing this one value in any other row?
No, ma'am.
No.
No.
It's violation of what constraint?
Foreign key constraint.
Referential integrity, I think.
Referential integrity. Correct. Which is also the foreign key constraint. Okay. So which rows are still referencing 1? This
6
row
and
and
7.
this
Last
row.
two rows.
So these two rows also have to be removed. Now, what all values of A are again gone? 6 and 7. These are also deleted. Now, any other rows using these two values in the C attribute?
8.
This one, right? This is
Third
using
one.
7, third one. So this also has to be removed. Now 8 is gone. Any C value using 8?
No,
No.
ma'am.
So now all the C values that are remaining, are they present in the A attribute also?
Yes, ma'am.
5, 3, 4, 4. These are present in the A attribute. So these are fine. So how many tuples are now remaining?
4, ma'am.
1, 2, 3, 4. 4 tuples. So the answer to this question is 4.
Ma'am, will you please explain again how you are removing the table rows?
Yeah, look. On delete cascade means what? The cascading effect is
Like if
seen
you
here.
delete the primary key, it will delete on
First thing is what is
foreign key
this
also will
this
be
entire thing?
deleted.
This entire thing is based on foreign key concept, referential integrity constraint. So when I have a foreign key which is referencing some other key. So foreign, what is the domain of this foreign key? Whatever values are present in the key that it is referencing, right? This is the domain of the foreign key. Now from here, let's say here the values 6 and 7 are present, and foreign key also contains the values 6 and 7 and 8. Some other values are there. Whatever values are there in foreign key should be present in the original key which it is referencing. Now if by some chance this value is deleted, then is it fair for the foreign key to reference the 7 value here in this row? No, because there is no reference to this value 7 in the original key, right? So the corresponding entire row has to be deleted. Okay. The
Yes,
same
ma'am.
effect is here. So this is the cascading effect. Because of one deletion, there are so many deletions. So first you delete 1156, that takes out the A value 1. Now 1 is being referenced where? In these two last two rows in C column. So these two also have to be deleted because these are violating referential integrity. Now 6 and 7 are also deleted. 7 is again referenced in this row. This has to be deleted. Now 8 is also deleted, but now 8 is not referenced in any other C value in this column, we can see. So the 4 rows that are remaining in the table, these are fine. These are not
Like
violating the constraint.
if we are deleting any row and the same row had in another foreign key, we delete that row also.
Basically, whatever values are not there in the original or referenced key, in this case A, cannot be accessed or referenced by C in any other row.
Okay.
Okay. So 4 is the answer. This is clear for everyone?
Ma'am,
Yeah.
how the same value in C can reference different values in A?
That is fine, right? C can see the domain of C is a proper subset of A. That means whatever values are there in A can be present in C, but nothing outside of that, right? So C can take as many times as it wants one individual value of A. See, this 5, this 4 is referencing this 4. This 4 is also referencing this 4. This is fine. You can reference as many times as you want. Okay.
It is quite confusing. Can you explain a bit?
Look, domain of A in this question is 1, 2, 3, 4, 5, 6, 7, 8, right? We can see 8 distinct values. So that's the domain of A. 1 up to 8.
Yes.
C's domain has to be what? A subset of this. It can be the entire set or it can be a proper subset. Right? Subset means what? If it is a correctly constructed relation, that means if A column has 8 values and C is also not null, then C column should also have 8 values. Right? Then this 8 values, not necessarily they have to each like one value references one value. It's not like that. Multiple values can reference the same value. Okay, so C column doesn't have a unique constraint placed over it, right? Only A column does because it's the primary key. Primary key has unique and not null constraints by default, but C column doesn't have that, so it can have duplicate values as long as those values are referencing the A column and are actually present in the A column. That's it. How many times I'm referencing the same value doesn't matter. Clear?
Okay, thanks.
Okay. Any other question from this one?
Ma'am, this 1156 is the tuple of the table which is given or A at root.
Tuple
From
means
which
what?
we are. Ma'am,
What is a
tuple
tuple?
means row.
Row.
Each
So
row.
tuple of a table, that means the entire row. So tuple 1156 means this tuple, this row where 1156 is present. Right? A values are not tuples, right? The entire row is a tuple. Okay, any other doubts? This is very important for quiz 1. Okay, this question is important. Okay, now look at this. The schema is given. So we have 3 tables: orders, product, and users. So how are they related? What are the foreign keys? First tell me, between order and product, which one is the foreign key?
Product ID.
In which table?
Orders table.
So this is the
Orders.
foreign key relation, right? And orders and users.
Similar user ID is foreign key for users.
Correct. Foreign key for orders, which is referencing the user ID in users table. So this is the
Oh, sorry.
referencing table. Okay, this is the reference table. Okay. Are there any foreign key relations between product and users?
No.
No. Okay. Now see the question. This is also very important. If the relations order, product, and users have 10, 6, and 8 rows respectively, what is the maximum number of rows returned by this query? Consider all attributes are having not null constraints. That means values are there in every attribute. So the query is just this: select star from orders, right outer join users. Okay. Just this. Just perform a right outer join between orders and users, where orders is the left table, right outer join users. So we are given the number of rows. Orders has how many rows? 10. Users has 8 rows. When will I get the maximum number of rows? So we just did a question like this.
When all the rows of users are common attribute with the rows of the orders.
When all the orders map to one particular user.
Correct. So here, between orders and users, what is the foreign key? I can see user ID, right? So if all 10 orders come from the same user ID, then how many matching rows are we getting?
10.
So 10 matches. Okay, 10 matching rows if all orders match to the same user ID. But how many user IDs are then left in the users table? We
7.
cannot find a match. 7 not matched rows. Right. So we have to take both into account. It will
17.
be 10 plus 7, 17 rows in the
17.
maximum case. So this question has been asked many times. Keep that in mind. Maximum right outer join, left outer join is very common question. Now this is an instance. Okay, this is also a good question if you are a bit weak in SQL. Do this type of questions. An instance of the relation students is given below. Which of the following query executed on students would result in the output given below? So this is the original table. Now I have executed some SQL query on it, which resulted into this output. So can you identify what changed here? Both are having
Name in
5 rows.
ascending order.
Okay, name is in alphabetically ascending order. Anything
Yes.
else changed?
Then if name is same, then SID is in
This ID
ascending
is
order.
different.
So since here Smith is 2 times, I can see, but originally this Smith mapped with 53688 and then this was 53650, right? So here now what happened that this Smith is mapping with, see how you can identify this first Smith had GPA 3.2, right? So it is the same row, but it has now gone down below this Smith with 3.2.
SID is also odd.
That means SID is also
It's
ordered.
better to match with SID because CGPA might be same.
No, I am just saying that, see, these rows are exactly the same. It's not like the Smith rows interchange the SIDs. Okay. Rows are exactly the same, nothing changing between two tuples. Just the ordering is changing. So the first you are ordering using SID. Look, you tell me which one is correct from here.
Third
From fourth
Option
one.
C.
On the test question.
C or D?
C, ma'am.
From C.
Third option.
So if I do C, then that is descending order. Is this a descending order? Yes.
It's not even an order right now. SID is not in order, right?
Look one thing. Okay. First, the order by clause is operating. First, order by is operating on which?
Name.
Name.
Name is an ascending or descending? Alphabetically?
Ascending.
Ascending. Then there is SID. Okay. So SIDs are just matching with names. Where do we see the ordering? Where there are similar names like these two. Now, among these two names, SID is an increasing or decreasing order?
Increasing.
Increasing means ascending.
So which option now? C or D?
Third option.
C.
Third option. Because ascending is by default the order that we take, right?
Ma'am, a
is
small
wrong.
question over here. If descending or ascending is given after like name and comma SID,
It is
after that
applying to both.
first it would apply to name, right?
Yeah.
Okay.
Okay. This is clear,
Ma'am,
right?
if we want to give only the want to arrange the name of SID in the descending only and keep the name in ascending, then in which way we have to write the query?
See, usually when you use more than one attributes, right, in a SQL query to order, usually we order them both in the same manner. Okay. We don't use like, I haven't at least used it. I don't know if this particular query will work. That if I do order by name ascending, SID descending. Why I am saying this? See, here if I did this, okay, if I did name ascending, order ID, SID descending. So first, what will be the ordering? Let's just do the name and SID column. So name is in ascending. That means it will take this ordering only, right? And then if I do SID descending, then it will replace these two, right? So it will be 53650 and then the 56 53688. These two columns, the ordering will change. But I don't know if this is the exact correct query to write this way because I haven't written. Let me check on this and I'll get back to you. Okay. I haven't written two different orderings in the same order by clause. Could be possible. I have to check once.
Ma'am, if we are seeing like both the
In,
Smiths
in the
and
case of in the
GPA is in
case,
descending order.
Come again?
ma'am, in the case of same name, the row will be arranged in descending order of SID. That is, select star from student order by names, comma, SID descending. First, it will arrange a name by ascending, and within the same name,
Look,
if it occurs.
here, what we can do is, if you want to do this ascending descending way, right, then the syntax will be like this: select star from students, order by name ascending, SID descending. Okay, what that will do is just put this row above this, and this will change the order. That's it.
That is the correct way.
Yeah.
Ma'am, in the fourth option, both name and SID are in descending order.
Here both the things are in descending order. That's why this is wrong. Okay.
Yes.
But if you just use here once, if you use ascending and then if you do descending, that is also wrong in this particular question, but this is okay to write the query like this. I mean, you can use two things in one order by clause.
ഇനി അത് വെച്ചല്ല അതിനകത്ത് പിടിക്കാൻ പോകുന്നത് എന്തു
Okay. Yeah. Any other question in this? Here for everyone? Okay. Do this one. This is very simple relational algebra question. So, what is the number of tuples returned by the following relational algebra expression where in students table we are selecting marks greater than 50? How many rows? Just according to the roll number, tell me which roll numbers I should choose.
Roll number 2,
6,
4,
4,
total 6.
5, 6,
6, 7,
7, 8.
Okay, these 6. And then I have to project the names. So how many tuples will be returned?
1, 2, 3.
6.
Rakesh is twice, ma'am.
So projection removes duplicates by default.
Yes,
Right?
that's
So
right.
the answer will be 5. That's the trick part of this question. Everyone will do, most students did what? They first did the selection and then they saw, okay, 6 rows in selection, so 6 in projection also. But no, this Rakesh will be counted only once. So it will be Rakesh Pranav, Emily Grace Levy, like this. Okay, 5 is the answer for this. See, in DVMS, that's the thing, because there is so much to remember, right? And this is just the initial 4 weeks. Later on weeks, we'll see the content keeps getting heavier every week. So you have to remember just the small things. Those help you in the questions. Okay, that's why I just do the PYQs. I will discuss a lot of PYQs when we go on for the later weeks, like 9 to 12. Those are the toughest weeks. Toughest means content-wise, those are very heavy. So we have to perform a lot of introspection in each question. Now see. Consider the student relation given below. Select the correct query or queries. So this is an MSQ. To obtain the last name of students whose age is more than 25. Now see, first I'll tell you here, there is only one wrong answer. For this question, I'm telling you myself. So you tell me which is the wrong answer.
Second one is
B.
wrong.
Why?
Because it is not projecting.
Because we
In
cannot
projection,
put
we cannot add conditions.
condition in projection, correct? And we do not do selection over projection, right? So this is wrong. Now, this one and this one, what type of queries are these?
Yes.
Tuple
Some relational.
TRC
Both are
and
different
first
ways of
one is
writing TRC.
relational algebra.
No, both are TRCs. Okay, both are different ways of writing a TRC query. Look, you can write it this way also, this way also. Both are correct ways. We have learned in this way. Okay, I have discussed in this way, but this is also another way. It is present in the slides. I have marked it that day.
Yes, ma'am. Yes.
Okay, so this one is doing what? See, here you don't do this matching part in the TRC. So this makes it a bit easier. You can directly write that, okay, T is the set of tuples that I am selecting, and from there I am projecting only the L name. So T dot L name, such that T is what variable is this? This is the variable that is representing the tuples of the student table that I'm selecting, right?
Like
So
which
student of
student?
T. Yeah, so
L name.
student of T and the T dot age should be, that is, this is the condition that for every one of these tuples that I'm selecting, the age should be greater than 25. This is also correct. Now, if I come here, what is different is I'm using a quantifier now. What quantifier is this?
Existential.
Existential quantifier.
Means what?
Ma'am,
There
there
exists.
exists
There
at
exists.
least one.
At least one.
At least one is there, like it exists. At least one such tuple exists in students table where the age is greater than 25, and what we are projecting is the L name. So here S is the quantifier variable. Okay, and this one is very straightforward. It's relational algebra. First select all the rows with age greater than 25, then project the last names. So if any of the last names are same, it will automatically get deleted, right? No duplicates. This is clear, right, everyone?
Yes.
Okay, this is a very good question. I didn't take this class. I think it was in week 2 or week 3. Usually I discuss this question in the class only. So consider the following relation in university database. So university has 3 tables. Student has ID, name, department name. Takes table has ID, course ID. Course has course ID, department name and title. So takes is sort of like a matching, right? Like which student is enrolled in what course ID. It is doing that. So student table has primary key as ID, course table has primary key as course ID. Now the question is asking which one of the following queries returns the ID and name of students who have taken all the courses offered by biology department. Okay, let's start option by option. I have taken only 3 options here. There are 4 options in the actual question. So obviously the correct option is among these. Let's discuss the first one. So here, what operation can you see? I am doing a set operation, right? I have a union. That means I have two sets of select from where statements. Let's decode the first one. What is happening here? Select distinct SID, S name from students table as S, where not exists. So not exist clause returns true when
the
There is
relation
no
inside
no.
not exist is empty.
It's false.
when the subquery returns null, then it will return true. That is nothing exists, right? But even if the subquery returns one tuple, then it is false. So what is the subquery? Select course ID from course where department name is biology. That means this part should give me what? All the course IDs in biology department. Yes or no?
Yes.
So if this set returns null, that means there are no courses in biology department, then only this not exist will give true. But does this make any sense? This set?
No, because it is going to be always returning the courses in biology. So not exist will become
See,
false.
what we are trying to find is I want the ID and name of students who have taken all courses offered by biology department. First thing is that if there are no courses in biology department, then why would I be doing this? And why should that be in the first set only? Right? Why am I doing this not exist? What is the purpose of this query? What is the purpose? Like if I execute this query, the information that I gain, the student ID, student name, what does it tell me? What is the meaning of the data? Nothing, right? It is to confuse you. So there is no connection between this part and this part. Because
But
first of
it will
all,
return if biology has no courses and
hmm,
the student does not pick any course, that will be the output of this query, right?
yes, see, first of all, in the if I could show you the database, you'll see obviously there are courses under biology. Okay. Otherwise, the question itself doesn't have a meaning. Who have taken all courses offered by biology means there are courses in biology. Right. If I still assume that there are no courses in biology, in that case, here the not exist is not checking whether the student has taken that course or not.
It's just checking there's a course ID or not.
See, yeah, if the course ID exists or not, that doesn't have any effect on the students table because students table, see the table, it doesn't have course ID column that you can match with. Okay, you should be involving the takes table. So this first option is solely to confuse you. This is not even close to correct. Second option is saying select distinct SID name from student as S where exists select course ID from course department then biology. Again, what is the point of this query? So this inner part will give me what? All the course IDs from biology. Exist clause returns true when there exists at least one row returned by the subquery. Right. So of course there will be rows because in the biology department there are courses. So this
But
will
we are
always return true.
subtracting, right? Inside only we are using except and subtracting.
See. One second, have I missed it? Okay, this entire thing they're saying is inside. Huh?
Yes.
Okay, let's do it again then. For the first option, here, okay, let me do the brackets. So this is the first set and this is the second set. The entire thing is not the set. Fine. Let's do the union between these two sets. So select course ID from course where department name is biology. So these are giving what? All biology course IDs. Yeah, that's what I was thinking. That am I missing something? Because it shouldn't be this meaningless. Okay. Union, what is the second set? Select T dot course ID from takes as T where SID is equal to TID. So what will this give? For a particular student, what will this part give?
Course ID of all the sub courses that is taken by the student.
Correct. So course IDs of all courses taken by a particular student. And these two sets union will give what? The set of all courses taken by the student along with all the biology course IDs.
The students, those who have taken the biology.
Same.
No, I mean the union of these two sets.
It will be same as course ID.
Course ID of the student taken biology.
Course ID of all the courses the student has taken along with all the biology course IDs. So this is not a meaningful data now. We want people who have taken all courses offered by biology department. That means we should try to find whether all the biology courses are present in the course IDs taken by this student. Right? Union is not going to do that. What will do that? If we can by some way intersect it, these two sets. Okay. So not exist, if I put on this, not exist will return true when nothing is returned. Union will return the entire set of all bio course IDs plus the course IDs taken by this student. So obviously this will give some value every time.
Return the student who have not taken any course, I think.
So if there is a student who hasn't taken any course, in that case this part will return null. Right, the second part, there will be no course IDs, but there are still course IDs from biology department and you're taking a union. So not exist will return false. Basically this query won't return any rows because not exist will always return false. So you cannot return any SID or S name.
Yes, ma'am.
Okay, now let's go to the second option. This is, okay, I should not put wrong. First, let's discuss it. So inner query, again, select course IDs from course by department name is biology. This is all biology course IDs, except, so select T course ID from takes as T where SID is equal to TID. These are all courses taken by a particular student. So from biology course ID, I am taking out what?
All the other courses except biology.
So this is the set of, let's say, biology has these three courses, bio 101, bio 102, bio 103. This is the first set. Okay, this is returning this. And for some student, let's say, if they have taken all biology course offerings, so we can say this student has taken bio 101, 102, 103, and he has also taken, let's say, CS 101. So I'm subtracting this second set from the first set. What is remaining?
Null.
Null. If null is returned, then exist will give what? True or false?
False.
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 But this was the correct student. They had taken all courses from biology. Right. So I should have written their SID and S name. So what part should be changed in this query?
Not exist.
Not exist.
Here I should put not exist. So that not exist will return true when there is a null. So that exact thing is done here, not exist, and the rest of it is same. So option C is correct.
It is removing from, like, it's removing all the courses, right?
See, what it is doing is, first it has the set of biology courses, all the courses that are offered in biology department. Second set is the set of courses that a particular student has taken. Now, if a student has taken all 3 biology courses, and if I take that, subtract that out from the set of biology courses, then it should give a null value, right?
Yes, ma'am.
CS101 is in the second set. What is cancelling out is these 3, right? But this is the first set, so this will give null. Everything is cancelled out. Null means that this particular student has taken all biology courses. They might have taken other courses too, that's not our concern. Okay, so whenever you get a null like this, that means this student should be in the resultant table. Their ID and name should be there, and that can happen when not exist is there. Not exists, right? Not exist will return true when it is null value. This is clear?
Ma'am, in a second option, what query could we use instead of except to get intersection of those
We don't use an intersection keyword, right? Whenever we need intersection, we do except only. By its that difference, we do intersection.
how could we read that here?
How could? Sorry?
I mean, how could we do that here?
We are not trying to do an intersection here, okay? We are trying to check if everything from first set is present in second set also. We are not trying to extract that common data. We are just trying to check if it is there.
I meant, ma'am, we could have taken intersection, and if that intersection matches with
But
the
but is there a point in doing double the work? I mean, if you take an intersection, then you would again have to match that intersection with all the biology courses, that these two are the exact same sets, right?
yeah, right.
So we are just trying to see if all the biology courses have been taken by a particular student. So just between these two sets, I'm doing a difference to see if the first set becomes null.
Yeah, thank you.
Okay. This is clear for everyone?
Ma'am, the question says that they should take all the biology courses, and
Yeah.
also they could take other courses we are not considered of, but all the biology courses should be included, right?
Yeah. Who have taken all biology courses, all courses offered by biology department. It is not saying anything about other courses, because even if they take other courses, it won't change the query.
Ma'am, over here, if they ask only biology courses, then how should we do?
Only biology courses. So in that case, it should be an exact match. That means then what we can do is we can take this set as the first set and this set as the second set. And then if subtracting leaves nothing, okay, see, then also it's not going to give the correct answer, because then if bio 101, if some student takes bio 101, bio 102, for them also the subtraction will give correct null value, right? We need to see if the exact IDs are there, okay? In this case, then except, instead of doing except, what we can do is just let's take out all the course IDs that this person is taking. Okay, and we have to check if this set is exactly similar to the biology course set.
Ma'am, instead, can we say only if courses are equal to department name is equal to biology, just give me that student name. Can we say that?
And which part do you want to change it?
Like not using except and all, just give select distinct SID and S name from student as S, and I'll do some natural join or cross join between takes and students, and I'll give where select course ID equal to.
But how do you know that that will pick every student that has taken every biology department course? That's a different set.
I'm doing from takes and students, right, ma'am? Cross join.
Okay,
I'm doing that.
okay. Tell me your approach. So from students and takes, I'm doing a cross join.
Yes, ma'am, and equating it with student ID.
Okay.
So all the non like
So
the
then
fake values will.
the course ID should fall among these only, right? The biology course IDs. Because you are trying to pick a student who has taken only biology department, all courses, no other courses. See, another thing I can do is, if a person, let's say this is the first set, this person has taken biology department courses and a fourth course, right? So if I take this as the first set, this as the second set, then the subtraction will leave what? not null value, because one other course is remaining.
Yes, ma'am.
So I can eliminate these students for whom this subtraction leaves some result. But why I am not saying that this is the right way to do it is because this will also give a null value if a person has taken just 2 biology courses.
Okay, if he is not taking all the biology courses, then also we'll get a null
Yeah,
value
yeah.
because he belongs to biology, but it's not
He
guaranteed
has
that he has
taken
taken all.
only 2 biology, but he hasn't taken all the biology courses. So this will
Okay,
cancel these
understood,
2
ma'am.
out. Okay.
Okay,
Let
got
me
it,
think
ma'am. I
about
got
this once. It's very easy. We just have to figure out how to do this matching for exactly the number of course IDs from both. Okay. I'll tell you this after the class. Let's discuss it a bit. You want that set of students who have taken all the biology courses and only those, no other courses, right?
Yes, ma'am.
Okay. I'll discuss this after I finish this PDF. Okay. Any other question from here, or everyone understood this question?
Ma'am, is there any way we can take intersection?
Intersection we usually do in
Ma'am, so
SQL. We
according to
use
the
except set difference. Direct intersection I haven't used. I mean, you can use, I guess. 1 second. Huh? हेलो ये मैं भी क्लास में हूँ थोड़ी देर बाद कॉल करो ठीक है Yeah, can you hear me? Yeah, so in SQL there is an intersect operator also. Okay, it is also a set operation that you can use in SQL. Intersect, it will give what? It will give you those distinct rows. So it removes the duplicates. Okay, just like we have that union all thing. So intersect by itself will remove all duplicates. It is there. But in this case, we are not using intersect. Why? Because we are not trying to get the intersection. We are not trying to get the biology course IDs. We are trying to check whether a person has taken all the biology courses or not. So here, the set difference is a better way to go. This is not intersect we are performing. This is simple set difference. If we want to represent intersect in the form of set difference, there will be 2 differences. Right? So if I want to do intersection of A intersection B, then the difference way is A minus B. This is not that.
Ma'am, ma'am, so like if the question, as somebody just asked right now, if the question was not all biology but just biology,
Exactly.
so
Yeah.
that means it would that means in that case the intersect would be correct, no? Because then I am not just considering people who have just taken compulsorily all, but I would also be considering those who have just taken either 2 or maybe just 1 bio course with something else, right?
See, I want to find people who have taken all biology courses and only those and nothing else, right?
Yeah.
So
So
that
it
means
depends on
if,
the question, right? In this
yeah,
case.
it depends on the question totally what operations you
Okay.
need to do. There in that case, except might work. I am just going to think about that a little. But intersect, I don't think is the way to go because again, you don't want to extract anything, right? You just want to check if those
Yeah.
sets are exactly equal or not. So we can just
Yes,
check
ma'am.
the 2 sets if they're exactly same. So what is the way to do that? That's what we have to figure out. That's it. Okay. One thing I can do is okay. I'll not discuss this anymore. Let's just finish these questions. Then I will come back to this at the end. Okay. Consider the table student and course as shown below. How many rows are returned by the below query? This is a very good question. See, except and except all. That concept is here. So first tell me what does except do? What does except all do?
except did not give the duplicates, while except all will also give the duplicate.
So that means if in the first set, okay, if in the first set there are n occurrences of a particular value, let's say, and in the second set there are m occurrences. If I use except, what will it do? It will remove all the duplicates and give me one occurrence in the result. But except all will give n minus m occurrence. Is this correct?
Why one, ma'am? Like, I can't understand that.
Except will remove all the duplicates in one go.
Okay.
Okay.
Right.
But except all will keep the duplicates.
Oh, okay. Here, n refers to like the same element.
The same, yeah, the
Okay.
same value. How many duplicates are there? See, you can understand this concept from this question. So first we are asking select ID from student comma course. This is a cross join. So if I do a cross join, how many rows will I get here between these two tables?
20.
20 rows. Okay. Now tell me, in those 20 rows, how many times is each student ID repeated?
4
5
times.
times.
4 times.
4 times.
4 times.
Yeah, 4 times.
So each ID is there 4 times. So then we pick the ID from this. Select ID from student comma course. So how many rows will I get in this first select statement? 20 rows. Right? We haven't written select distinct ID, we have written select ID. So it will give all 20. Then you have except all, select ID from student. So select ID from student will give how many IDs?
5 IDs.
5 IDs.
5 IDs. Just from student, there are 5 distinct IDs, right? So select ID from student cross join course will give 20 rows. Now from this you are doing except all 5 rows. So how many IDs will still be left?
15.
15. Because see, each of the IDs is just removing one occurrence. This is except all, not removing all the duplicates, right? Just one occurrence is cancelled out. So 15 rows are still remaining. So in this 15 rows, how many times does each ID appear? How many times each ID appears in this 15 rows?
3 times.
3 times.
Times.
Because one occurrence is cancelled out for every ID by these 5 rows. Now the second except all is again applied on this 15 rows that are remaining and select ID from student. So again you have 5 rows. So 15 rows, then except all, again 5 rows. So now how many rows are remaining?
10 rows.
10. In these 10 rows, how many times is each ID repeated?
2 times.
2 times. Okay. So now 2 occurrences of each ID are remaining. So how many rows are returned by the entire query? 10 rows. This is clear?
Ma'am, once again, could you repeat?
Yeah, see. First, what we are doing is select ID from student comma course. That means that's just a cross join. So how many rows are there going to be in the cross join of these two tables?
20.
20. In those 20 rows, understand this way. In those 20 rows, how many times is each student ID repeated?
4 times.
4 times. Okay. So select ID from student comma course. In this cross join, I haven't written distinct ID. That means all IDs values will be selected from the ID column. So how many values will be selected in the cross join? 20 rows.
Yes, ma'am.
Then you have except all. Except all, what is the second set? Select ID from student. So if you just select ID from student table, how many IDs are there?
5.
So except all 5 rows. Now if you take out this from this, how many rows are remaining?
15.
Now what are these 15 rows containing? See, these 5 rows are unique IDs of each of the students, right? So every occurrence of these student IDs are cancelled out just once. These 20 rows contain 4 occurrences of each student ID, from which one occurrence is cancelled out for every student ID. So now in these 15 rows, how many occurrences are remaining for each of the student IDs? 3 occurrences.
Once it is removed, right, ma'am? Once each 5
Once
are
each of
removed.
the IDs are removed. Yes. So for every ID now 3 occurrences are remaining. That's why 15, 3 into 5.
Okay, understood. Okay, now I got it, ma'am.
Yeah.
Ma'am, if
Again, do
except is
all.
written,
If
like I
except is
understood.
written, then here if you remove this, only 5. Actually, nothing will be returned if you do except.
Except
Everything
would
is done.
remove 0, right? Like
Yeah,
it would
it
give
will
0.
give 0. It will give 0.
Got
Everything
it.
is done.
Yeah. Thank you.
Ma'am, do we want any precedence while doing this query? Like here we use except all here, but if I have union intersect, like if I'm just using In the first thing I'm using union, in the second I'm using intersect.
No,
How
if
do
if you're not using any brackets, then the precedence is the order starting from the first line and second line like this. But if you have brackets, you execute the parenthesis first. Like if this was in a bracket, then this is the first set, this is the second set. First you execute this one and this one separately, and then you do the except all between these two sets.
Okay, if no brackets are there,
Then you
like,
just do it in the given order. First line, second line, third line, like this.
Ma'am, if this goes like this, then select ID from student except all select ID from student, then it would give 0, right?
Select ID from student except all.
No. The last 3 lines, if we trigger, sorry, if we.
Oh, here, if you are saying if I remove the all, or
Yes,
here,
no.
even if
If
I
we,
keep the all, if I keep it in parenthesis, right?
yes, ma'am.
So select
If
ID
we,
from student except all select ID from student. So this is 5. One occurrence of each will be gone. So this is a null set.
yeah, because they're repeating like once
Only
each,
one.
so we
Yeah.
remove all
Yes.
of them. Okay, got it.
Yes.
Thank you, ma'am. Yeah.
Ma'am, by using this table, can you give the example of union or all and intersection or?
Union all. Okay. See, union all and intersection all we don't use. We use union all, union except all. Okay. Because here, if I do union, how do I do this in here? See, first let me tell you what is union all. First, if I do union, then everything is there. Okay. Union all. Union compatibility. First, tell me what is union compatibility.
The corresponding attribute should have same domain type or data type.
Anything else?
the number of attributes.
So the fundamental difference between union and union all is what? How they handle the duplicate rows when we combine the results of the two or more select statements. That means we can perform union between two sets at a time and then again with a third set. So how you handle the duplicates when you're joining these two sets, right? So union, what it does, it will combine the result sets of multiple, or let's currently talk about two sets. Okay. So it will combine the results of both those sets and it will remove the duplicate rows. Okay, whatever is duplicate, it will remove. So if you do a union, no duplicate rows will be present in the resultant query. But when you do union all, it will not do that. Okay, union all in the columns. So what it does is it will keep the duplicate rows. So which one will take more processing time? Union will take more processing time because it has to identify the duplicate rows and remove them, but union all is faster because it keeps everything that is coming, even if there are two or more duplicates. Okay. But union compatibility makes sure that the names and data types of the different columns in the select statement are compatible. In this example, if I want to show union all, let's do the cross join only. But that's not. See, if I take this first set, okay, for union you don't even need a cross join. So here if I just take the first set as select ID from student, okay, union, same thing, select ID from student. What happens here? How many rows will be returned? If I
5.
Yeah, 5 because duplicates are removed. But here now if you add union all, how many rows will be returned?
10.
10. Okay, this is how it works. Just union all will keep the duplicates, so it is the faster one, and
Ma'am,
union requires more processing.
if we use like not the same statement, like the other course statement, then it would just add, right?
Then it would just add. See, if I do select ID from student and select, let's say, course ID from course. In that case, see, are any of the rows here completely
They're
equal to
not
any of the
repeated.
rows? Nothing is repeated. So
Yes,
here,
ma'am.
union will also give 1, 2, 3, 4, 5, 9 rows. Union all will also give 9 rows.
Yes, ma'am.
Okay, if there are completely distinct sets, only the difference is spotted when there is a common, something in common.
Yes, ma'am.
Look at this schema. Now I have students, teachers, enrollments, courses. You can identify the foreign keys, right? Using the arrows. Now this is the school information system. So you don't have to go through in all of that detail. Just see this is a very simple select from where query. You have to choose the SQL query that will give output first name and email of all teachers whose phone numbers end with 8 and who do not teach history. Okay, so first one, if I check, I want first name and email of all teachers whose phone numbers end with 8 and who do not teach history. So which table do I need, or tables?
Teachers.
So for the phone number checking, I need the teachers table. Now, who do not teach history? For that, I need
Course
the course
name.
name.
Courses name.
So courses also needs to be taken. So these two tables I have to join, right? Teachers and courses. Nothing else is required. So select teachers first name, comma teachers dot email from teachers natural join courses. So I'm doing a natural join. Is that possible here?
No,
Natural
no,
join.
ma'am.
Why not?
It is
Yes,
possible,
ma'am.
ma'am. Course ID.
On the basis of course ID.
Course ID I can do natural join, right? Okay.
Yes.
If I do natural join, and then I'm writing that where phone like %8 means ends with 8. And course name, this is what?
Not equal to.
Not equal to history.
Not history.
So is this correct?
Yes, ma'am.
Yes, ma'am.
Correct. Okay. Why is the second option wrong?
Because it's not equating, not Not like.
That is fine. I mean, you are doing course names, that is a string matching. I can use not like if I want.
It is cross
It
join.
will.
Cartesian product in second
It
one.
will be the
No,
Cartesian
it
product.
is inner join only, right, ma'am?
It is inner join. But you have not specified. It is not correct syntax for
Yes.
inner join. You need to specify.
We need to specify the to
That
which
you are
common
doing, yeah, course ID.
joins we're doing. Yes, ma'am.
Yes. So that's why this one is wrong. Again, why is third one wrong?
The like operator. We are
After 8
checking
there is
second last character.
Right. So there is
Dash,
one more. So
dash.
8 becomes the second last character. That is wrong. And this one is very simple. It starts with 8. This is wrong. Okay. So first one is correct.
Ma'am, second one is wrong because we are doing the Cartesian product instead of inner join or natural join.
Join means what? Is join Cartesian product?
Yes, ma'am.
Join keyword in SQL. What is cross join then?
It is equivalent to Cartesian product.
So join keywords is equivalent to inner join. Right. Inner join you perform between two attributes from two different tables, but you have to mention that from teachers join courses on teachers.course id is equal to courses.course id. Then it would be a complete query. Okay.
If we are not giving the condition, then
Inner
then
join
with
cannot
join.
work. No. If it was natural join, it will by default take the common attribute. But if you're using inner join like this join, then you have to specify, right?
Ma'am, if not specify, it will return a empty table or.
It will not perform the join.
Okay.
Okay. Now this is also very easy. See how many tuples will be there as a result of the following query. So outer query is doing what? Select employee ID from employee where employee.age is greater than all of whatever is returned in the inner subquery. So subquery is returning what? Select manager age from manager where manager name is Reina. So is there a manager of this name?
no, ma'am.
So what will the inner query return?
Null.
Null.
So it will not return anything, right? And then you have to check that which of the employee IDs are greater than whatever is returned in this. So how many employee IDs will be selected?
5.
All 5. But remember
Right.
one thing, you cannot directly compare with null. Okay. This is a result of a subquery. It is not returning anything, it is empty. But you cannot directly just say that employee age greater than null, or just don't do any direct comparisons with null. Okay, null is not compatible with direct comparisons. So this particular one, it will return 5. Okay.
Because it is given with all, right?
Yeah, it is given with all.
So null is not comparable to 0. That is why you are saying that.
So null is not comparable at all. Okay. In any case, you cannot directly compare with null. Null is used in cases like exist, not exist. Those cases where you can get a value out of it, Boolean value.
Ma'am, if there wasn't all in the third line, then will it return an error?
Yeah, it will give an error.
Okay.
You're directly comparing. Yeah.
Ma'am, what does all? Sorry, I forgot. What does all does? Like,
All
would it
means here,
select?
let's say here, if I put an okay, that is a name that actually exists in this manager table. Then what is the age that will be returned? 20.
20, ma'am.
Okay. Then here in this case, it is returning only one value, right? But I might say, let's say, return the age of all, select manager age from manager, where manager name is 5 characters long. Exactly 5 characters long. Okay, forget this one, that will make more sense. So if I have manager name exactly 5 characters long, then how should I write this? Manager name
Under
Ma'am, 5 underscores. 5
yeah,
underscores you
under
use.
colons we need to put 5 underscores. Yeah.
This will work. Okay. How many rows will this return?
2 rows.
2 rows.
These two. Okay. And I am selecting the age. So this will return 18 and 19. These two ages. So now you have to select all the employee IDs whose age is greater than 18 as well as 19.
Okay, ma'am.
So this will give null. Okay, because here all the employees are.
Understood. Yes, ma'am. Got it.
Yeah. Okay. This one is purely your relational algebra query. So you have 3 tables: passenger, pilot, booking. Passenger is taking PID, passenger ID, PName, BID. Okay. Pilot is taking pilot ID, pilot name, flight number. Bookings is taking booking ID, boarding, destination, flight number, PID, pilot ID, all of these. I think this BID is related to, it is a foreign key for booking ID. Okay. So you have to choose the suitable query that will find the names of all passengers. So I want names, right? So name should be projected. Names of all passengers means which attribute in passenger table? P name. Okay. Who flew from New York with pilot named James Van in flight number 3005? So what all information I have? Flew in from New York. That means
Boarding.
Boarding is New York. Okay. Pilot name we have James Van, and we have flight number. So flight number is present here also, it is present here also. Now let's check the first query. Look here. Okay. Try to work it from the innermost parenthesis. So if I do pilot, since, why am I saying innermost parenthesis? Because you can see the projection is correct. It is projecting P name, right? All of them are projecting P name. So by looking at this outside, you cannot say anything. Let's see the inner working. So pilot, natural join, bookings. Is it possible to do natural join between these two?
Yes, ma'am.
Based on which?
Flight number.
Flight
number. And also I have pilot ID.
Pilot ID also we can.
Okay, so both I have. Okay, if I do a natural join, then on the natural join, I'm doing selection on boarding is New York. So is boarding present in the natural join set of attributes? Yes, it is coming
Yes,
from
ma'am.
bookings table. So boarding is New York and flight number is 3005. That is also fine. Pilot name is James Van. That is also fine. Anything else we missed? All the conditions are there. Now from here, I am projecting PID. From here, can I project PID from the natural join?
Yes, ma'am.
PID
We
is
can.
present. Okay. So I project all the passenger IDs for whom all these conditions are correct. and then I do a natural join with passengers itself. That means what will this give me?
All the passenger flying from New York to
All the
Seattle.
tuples with the passenger details who match these PIDs,
Yes, ma'am.
right? And then I'm projecting their names. So is this correct?
Yes.
Yes.
It does look correct. Okay, let's see why option 2 is not correct.
Option 2 is doing a pilot name and passenger natural, which is not possible.
Not possible because it is not present in both the tables. So here this is the error. In option 3, here up to this I can say everything is same. Boarding,
Passengers and
check-in,
bookings are done over there, ma'am.
right. So
Natural join.
passenger and booking if I do, then what can I not do? Pilot name I will not have.
Yes, ma'am.
Right. So I cannot check on this pilot name James Wan. So this is wrong. Again, pilot passenger if I do, then I won't have the boarding destination. Right. So pilot passenger, I won't be able to check this boarding.
And flight number also.
Yes,
Flight
ma'am.
number
Yes.
I have in pilot, right? That's why I'm not saying that.
Okay.
But boarding is not there. Okay, so these three are wrong. First option is correct.
Ma'am, why not passenger and bookings?
Passenger and bookings, if you do, what can you not do? Here, see, in bookings you have everything. In passenger you have this, but do you have the pilot name? That comes from pilot table. Right, so you have to check that pilot name is James Wan. That checking you cannot do. Okay, I think 4 marks is still a lot for this question, but 3 marks is okay. Let's see. This is clear for everyone?
Ma'am,
Hmm.
then how the natural join perform with two common columns
It
like
will take both columns.
pilot ID and flight
It will
flight
take
number?
both columns and take the combination of those columns values.
Okay,
Okay.
combination of those.
Yeah, like we did in that first left outer join question, right? We had two B and C, two common attributes, so we took the combination. Natural join also
Actually,
does
ma'am,
that.
I joined late.
Okay. See, in natural join, if you have, you don't get to specify based on what attributes you want to perform the natural join, right? So it will take everything that is in common,
Yes, ma'am.
and it will check combination wise.
Okay.
Okay. Any other question from this one?
No.
Okay, let's see this. So this ER diagram is given. What is the minimum number of tables required to convert ER diagram into relational model? So ER to relational model, I hope you know the rules, right? So first tell me how many tables we need for the entities itself.
3, ma'am.
Three. One for
tables.
teachers, one for students, one for courses. So 1, 1, 1. Okay. Now what are the relationships like 1 to 1, 1 to many, many to many, many to 1? What is this
Many to
instructor
Many to
telling?
many.
Many to
Between
many.
student and courses, many to many.
So many to many relations require, do they require a separate table for the relationship
Yes, ma'am.
itself?
Yes, ma'am.
One table here. Again, students and courses, this enrolled is many to many or not?
Yes,
Yes,
ma'am.
ma'am.
Many
Yes,
to
many to
many.
many only.
Yes, so one extra table for here. Now, what other tables will I need? Do you see any tables I will need extra?
Ma'am, for the
No, no.
attributes which are
Okay.
taking the multiple value attribute, we need one more table.
Correct. So multi-value attributes take separate tables. One for this phone number from students, one for this phone number from teachers. So how many in total? 7. Right, 7 tables I'll need to convert this into relational model. Now, some other important questions from here. Is it necessary that, okay, tell me this. Can there exist a student who is not instructed by a teacher?
No, ma'am.
No, ma'am.
Why not?
Ma'am,
Because
because
completely dependent.
participation.
Total participation is
Participation.
there, right? So these double lines, these mean total participation. Okay. So this type of question can come. Here 7 is the answer. One more ER diagram question we will do after this. Okay. Consider the SQL query to create an insurance and nominee. These two tables as shown below. Okay, so create table insurance. It has insurance ID as the primary key. Policy holder name, that is also not null. And age is also not null. Premium is also not null. Okay, and nominee table, we have nominee ID, which is primary key, nominee name, relationship, insurance ID, foreign key, insurance ID, references, insurance ID, on delete cascade is there. That means this insurance ID in nominee table is a foreign key which is referencing this insurance ID, right? And on delete cascade is applied. So instance of the two tables are given, insurance and nominee. Now question is asking, the following SQL query is executed, delete from insurance where insurance ID is INS001. Okay, remember this is the foreign key, this is getting referenced, this key. So INS001 is deleted. Okay. Then is anyone taking a reference from INS001?
No, ma'am.
No one is taking reference from this ID in the nominee table?
First one
Shakti is
is
taking,
pending.
right? Okay,
First one,
sorry.
ma'am.
This one, right? So this will also get deleted. So what will be the, okay, now if this gets deleted, nothing else is getting deleted, right? Only from insurance I have deleted INS001 and only one table in nominee was referencing that. So nothing else. Okay, let's see if anyone else is directly dependent on this ID. No. So what will be the value of x is if x represents the total number of rows in insurance and nominee table counted together. So how
5.
many rows are remaining? 3 here, 3
3,
here.
5, ma'am.
2.
So 5. This is easy. Now in this same question, it is saying insert into insurance these values. Okay, so now we are adding some more insert statements. So insert into insurance values INS005, Rakesh 24, 7000. Okay, first see if this is a valid insertion because the primary key has to be unique. So is INS005 present already in insurance table? No.
No,
So it
ma'am.
is a valid insert. Okay, all 4 fields are there. Since not null is applied, all 4 fields are there. Again, insert into nominee values NM004. So the nominee ID has to be unique. It is unique. NM004 is not present. I can add it. So name is Sonu and then the relationship is son and it is referencing INS005. So it can reference since this row is now added INS005. Now next one is insert into nominee values NM004, Suman, wife, INS004. Is this a correct insert?
No, ma'am.
No,
Because
ma'am.
nominee ID is same,
Yes,
right?
ma'am.
So it has to be unique. So this one is not valid. Insert into nominee values again. Can I do this?
No, ma'am.
No.
No.
Insert into nominee ID, insurance ID. See, in nominee table, if you check this, here not null is applied where only on nominee ID because it's the primary key. Okay, all other attributes can take null values. Okay, so here I can see I am inserting only into nominee ID and insurance ID. Nominee ID is NM010 and insurance ID is INS005. Is this valid or not?
Yes, ma'am.
This is
Yes,
valid.
ma'am.
So I can insert NM010 and INS005. So what will be the output of the below query? Select star from nominee. So currently in nominee table, how many rows are there?
5.
5. 1, 2,
Sorry,
3.
Let's
4. 4.
4.
First one is removed.
check from these two. Okay. Now see why this NM00, I'm sorry, this number 1 row is also there. It's because
It's a different
we are
question.
applying this on the table instance that is given, right? We are not applying
Yes,
this
ma'am. Yes,
after
ma'am.
the 11 question is done. These are two different questions. So based on this, which one is the correct answer?
Third, ma'am.
Option
Third.
third.
Last one.
This one. Yeah.
Third.
So here 1, 2, 3 are there and 004, 010 is also there. So these two are null values. Okay. Again, okay, this one. This is a good SQL question.
But ma'am, we removed the first row, na?
But that was a different question, right? That
Okay.
question does not have effect on this question. These two are, this is the common data for both of these questions.
Okay.
Okay. Usually comprehension type questions like this will be at the end of your paper in the exam. Okay. See, consider the relational schema given below. So we have a drivers table, we have a designations table, and a brands table. Drivers table has driver ID, driver name, brand ID, designation ID. Brands table has brand ID, brand name, and designations table has designation ID, salary. Okay. See, this designation ID is the foreign key, which is referencing this designation ID primary key in designations table, and brand ID is also foreign key referencing brand ID in the brands table, which is a primary key here. What will be the result of the following query? So this is again set operation. Now we are using intersect. Now see what is the first set giving. Select driver name from drivers D, natural join designations T. So first I am doing a natural join between drivers and designation. It is possible. Based on which attribute?
Designation ID.
Designation ID. Okay. So T is the line I'm using for designations table. So where T dot salary is greater than all. Now what is this set? Select salary from designations, comma brands, comma drivers. That is all three tables. I'm now doing a cross join where T dot designation ID is equal to D dot designation ID and brand ID is equal to B dot brand ID is equal to D dot brand ID and B dot brand name is equal to Mercedes. Now understand this inner query very well. How is the join happening? T dot designation ID has to be equal to D dot designation ID. That means I am matching the designation ID. Between which two tables? Drivers. See, D is for drivers, T is for designations, B is for brand. So driver and designation. I am matching what? The designation ID. And brand ID I am matching between brands and drivers. That means all three tables are now joined. Up to this, is it clear or not? All three tables are joined. Then you have B dot brand name is equal to Mercedes. So now this part of the select from where query is giving what? Salaries of drivers who are in team Mercedes or brand Mercedes. Okay. So then you are giving this output to the outside query that you have to select the driver name from drivers natural join designations T where T dot salary is greater than all salaries of drivers from Mercedes. So what is essentially the first set? Names of drivers who
Whose
are in
salaries are greater than Mercedes team drivers.
correct. Driver names whose salary is greater than all Mercedes drivers. And now look
Ma'am,
at
sorry for interrupting. We are using natural join because the
there is
attribute
only
names are same.
one attribute name is same and only one common attribute is there.
Okay,
So natural join is the better choice.
got it.
Okay. So this is the first set. Now look at the second set. It is very similar. Everything is same. See, what is the change here between these two? Only the brand name is.
Brand name Ferrari.
So this means that this second set
Driver's
is
salary is less than Ferrari.
Less than.
Greater
yes.
than Ferrari.
No, it is less.
Then
Right? This is also
less
a difference. So we are getting the names of all drivers whose salary is greater than all drivers from Ferrari team. Okay. Now if I do an intersect of these two sets, then you now look at the options and tell me which one is correct. You know the sets. First set is set of drivers whose salary is greater than all Mercedes drivers. Second set is set of drivers whose salary is less than all Ferrari drivers. So which is the correct intersect?
A,
First one.
First
A,
option.
A, ma'am.
First
First
Less
option.
than all Ferrari drivers and greater than all Mercedes drivers.
correct. So names of all drivers whose salary is greater than all Mercedes but less than all Ferrari. This is the correct one. So this is not difficult. See, it just looks big. Okay. Next, what do we have? This we have done multiple times in the last class. So I have food items table, we have item info table, doing division. Division, how do we do? You all remember we have discussed it intensively using the relational algebra also, but this is the basic one. I told you usually in exam we'll give you two tables only, right? So now you're doing food items divide by team info.
Yes, so it is for each
Item info.
item.
Yeah.
For each item, how many
So we
brand?
have to find out what is the not common column. Tell me. Item name. Right.
Chocolate, ice cream.
So we have to find out which item has both
Yeah.
these combinations correspondingly. Chocolate has one combination with Amul 5. Chocolate has another combination with Nestle 4. So can chocolate be in the result?
Yes.
Yes, ma'am.
Yes. Ice cream has Nestle 4
No.
but no Amul 5. That means ice cream is not in the result. So chocolate is there. Check for cake. Amul 5 is there. Nestle 4 is there.
Yes, ma'am.
Cake is there. Candy. Amul 5 is there. Nestle 3 is there. So only chocolate and
Candies,
cake
no,
are
not
going to
one.
be there. So option D. Clear. This
Like
Once
tell me,
please explain.
how does division operator work? First, if I have table A divided by table B, that means we will see that what are the columns in table A which are not in common with table B. Right. In those columns, we'll see which values have corresponding all combinations from table B. For example, here, what is the column that is unique in table A? Item name. Right.
Yes.
What are the two combinations? What are the two combinations in item info?
Amul
Amul
and
5.
Nestle.
Amul 5. Okay, both. You have to take the entire combination. These are both common columns, right? Brand and rating. Amul 5 is a combination, Nestle 4 is a combination. So you have to pick all the item names for which both the combinations are present. Like for chocolate, there is one entry for Amul 5, one entry for Nestle 4. So chocolate is going to be one of the division results. But for ice cream, we have Nestle 4 but no Amul 5 combination. So it is not there. Understood?
Like we have to see Amul and Nestle common combination with item name.
Not just Amul Nestle, you have to take the whole combination Amul 5, Nestle 4. This entire combination. So you have to check which of the item names have both these corresponding combinations present. The reasoning of all of this you can understand better if you see the previous class video where we did relational algebra query part of the division operator. Right? This is clear for everyone?
ma'am, like
Yes.
what is the like significance of doing division operation? Like what meaning the query output gives?
The meaning is like here, if I want to find out in this particular question, see, this tells me, so if I have a brand like item info table like this, I want to know that which items come from both these brands having this exact rating. So this is a type of filtering. Division is just a type of filtering. Okay, so instead of writing the whole relational algebra query where we specify the conditions, so here you can directly do that condition using the division operator. You can have anything in the second table, right? If I have just a normal table, one table, from there I can just take, let's say that table has 4 attributes, I can take 3 attributes out if I want to if I want to use some filter on those attributes, and I can create a second table and then just insert those rows which I want to keep in the filter. Then I can match with both the tables in a division operator and just pick the unique item, unique column items which has a combination for each of the rows in the second table. I mean, division operator significance is that it is a type of filtering. Like here, the filtering is that we want those items which come from both these brands with this exact rating.
Ma'am, like here we have candy also from Amul, but candy not from Nestle.
Candy is there from Nestle here,
Yeah, but
but rating is not.
rating is not 4, na?
Yeah. So you have to check on both the attributes. Whatever is in common, there can be 3 attributes in common also.
And how this operator handles duplicates? Say for
That for
example,
that you have to check the relational algebra query that we solved in last class. So it
okay,
takes projection. Okay, so all duplicates will be inherently removed.
okay.
Mm, okay, yeah. Any other doubt here? These questions are the scoring ones. Okay, this takes barely 1 minute to do, and you'll get 4 marks. Okay, this is from again week 1. Consider relational schema. This instructor to change the data type of ID, this attribute. Which of the following categories of SQL command is used?
DDL.
DDL.
DDL. Okay. Everyone knows, right? Which
Ma'am,
part?
because we are changing it for the core part, that's why we are
Schema part.
using
Yeah,
DDL,
you're
right?
changing the data type itself. So you cannot do that using DML commands. That is part of the schema. Right. So anything changes you make in schema is using DDL.
Like DML would be right if we are just changing the ID name, like the ID
Yeah.
value.
If you're changing the value,
One two
manipulating the
two or
table
two two
itself,
three.
yeah, then you
Okay,
can use DML.
ma'am. What is TCL, ma'am? Like in week 5, one of the questions TCL was there. I don't remember.
TCL commands in SQL, those are transaction control language. Okay. So those are like commit, rollback, save point. These you will learn in week 10. TCL.
Okay.
Ma'am, TCL's example is like banking and all.
Yeah, transaction related. So the entire week 10 is about transaction and serializability. That is one of the toughest weeks of this course. So there we'll learn all of these commands, how they work. Okay. Yeah, this table now see. Which of the following queries will find out the names of all instructors whose department is finance or whose department is in Watson or Taylor building? So two things in your wire clause should be there, that either it is in finance department the person is from, or the department he is in Watson or Taylor building. So do we need one table or do we need two tables?
Two tables we required. Right.
Two tables. Okay.
Two tables.
See these first. Let's have the first two options. So select name from instructor I department D, where we are joining using department name. I mean, this is a cross join, and then we are filtering out the rows with the same department names. And I dot department name is finance. So this is the first thing, first condition, that the department of the person is finance, or building in Watson Taylor.
This one is correct, ma'am.
This looks correct. Select name from instructor I department D, where department name is finance, or building in Watson Taylor. Is this correct?
Ma'am, they have not given
No.
I dot
Yeah,
depend.
this is the perform
Sorry,
condition.
So here, since
cross
this is a
join, right?
cross join, it will give all possible combinations. So this won't be correct. Again, this third one, select name from instructor I department D, where the join is done, and okay, here and
There
operator
should
is
not
being
be
used.
and.
Right, this should be or. Last one, what is wrong? Natural join I'm doing. Okay. So is natural join not possible here? Instructor and department, if I do natural join, I can do one department name.
Yes, ma'am. This is MSQ question, right?
Possible.
Let's see if this is an MSQ. Yeah, it is an MSQ. So last one, is it possible?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Department name only, right, ma'am? We can.
So both are possible, right? Option 1 and option 4, both are correct. I'll just annotate it once. Okay, this consider following SQL statement. So we are creating a table called cars, where we have car ID, car name, car color, year of purchase, which is integer type, primary key is car ID, check. So now check statement, are you familiar with?
Yes, ma'am.
Yes, ma'am.
Okay. So check statement is saying that year of purchase should, yeah.
Ma'am, one doubt. Previous question, there is only one correct answer.
No, two correct answers are there. Last one is also correct.
These type of questions have only one correct answer.
MSQ question it is.
No, this is MSQ, no? Multiple select.
Okay.
MCQ will have one correct answer.
Excuse me, one thing I may ask. In natural join, it is possible only when there is some
common attribute, and the name of the attribute is also same.
Okay.
Ma'am, regarding name, I have done an example and also created a discourse post. If we do not have same name, then also it is possible.
Do not have same name. Natural join.
Yeah, I have done and also created a discourse post on that.
Okay, let me check once after the class, because usually I have done, like, all my life I've used using same name. Could be, maybe I'm missing something. I'll check it once. Okay, after the class. Okay. Consider the following SQL statement. Okay, the check part is saying what? That year of purchase should be in 2001, 2, 3, 4. Okay. The following tuples have already been inserted. So currently my cars table contains these two tuples. So which of the following will cause an integrity constraint violation? So there are 4 insert statements. Again, this is an MSQ. First one is saying insert into cars C3. So this is fine. I can have a unique car ID.
Ma'am, last
McLaren
one.
orange 2003, because year of purchase is, this is fine. Year of purchase can be
Yes.
Orange color, ma'am.
2003.
Color.
Okay. Do we have any constraints on that?
No.
Only constraint is that year
Only
of
on year.
purchase should be this among these 4.
Oh, okay.
So
Sorry.
first one is correct. Okay, we can insert it. This will not cause any integrity violation.
And
Second
second,
one, why it is integrity violation?
ma'am, because primary key is
It's already
repeated.
present.
Primary key
Right.
repeat.
So this is primary key violation. C2 you cannot have again. Again, this one, third one, this is answer. This is not answer. Third one, insert into car C4 Williams Black 2002. This is possible.
Yes,
Yes.
ma'am.
Last one, insert into car C5 Alpha Tauri Blue
Not possible.
2005, ma'am.
2005.
Not possible.
2005 is not in our check statement. So this A and D are wrong. Okay. I think this is the last one. Yeah. Consider the ER diagram.
Ma'am,
Which
you
of,
put the wrong selection. Is
sorry,
answer in third.
this is correct.
Third one is then
No. Third one, here what I'm marking is that what is our answer. Okay, tick means this is our answer. So which
yeah.
among the following will cause an integrity constraint violation? So B and D will cause the violations. This
Okay,
causes
okay.
primary key violation. This causes check violation.
Okay.
Okay. Now see the ERD. We have company, items, customer. Okay. Let's understand the table. So items to company is what type of relation?
Many to one.
Many to
Many
one.
to one.
Many
The
to
one
one.
side is this, the arrow side is the one
Yes,
side.
ma'am.
Customer and items is a many to many relation.
Yes, ma'am.
Again, which of these relationships is partial participation?
Order
Item.
to item.
That means item
Items and
entity has
orders.
partial participation in orders relationship. Okay. So you understand these two concepts properly. Now you tell me which one of these statements are correct. There might exist a company that has not produced any items. So can there exist a company which has not produced
No,
any?
ma'am.
No, ma'am.
No.
No,
This
ma'am.
is total participation. So
Total
none of
Total
that
participation.
can
participation.
happen. Okay. First one is wrong. There might exist an item that has not been ordered by any customer.
Yes, ma'am. That's
Yes, ma'am.
Partial participation. Okay. It might not take part in the relationship. This is correct. A company can produce at most one item. Company is the one side. This is the many side. That means company can produce
It can
many
produce
items.
many items. Yes, ma'am.
Right. But
It
every
already
item,
says items, plural form. Then how can?
no, this is just the name of the tables. Okay. This is fine. This is just table name, entity name. But it is asking that a company can produce at most
No,
one item.
wrong. It's wrong.
Wrong, ma'am.
A company can produce more than one item, but every item must be produced by each individual company, not more than that, because company is the one side. Okay, so this is wrong. A customer can buy more than one item.
Yes,
Yes,
ma'am.
ma'am.
Customer
Ma'am,
can
could
order
you
more
repeat the
than
third
one.
option once again, ma'am?
Yeah, company can produce at most one item. It is saying. So company can produce as many items as it wants, right? Because company produces, this side is the one side. That means company produces many items. This is the many side. But items can be produced by exactly one company. Every item is produced by exactly one company.
Like if there are different type of products, one product, each
Like
product.
let's say if you have item 1, item 2. Item 1 has, if item 1 is produced by C1, okay, item 1 cannot be produced by C2 as well. This is wrong. Item
Okay.
Every
Yes, ma'am.
item is produced by one individual company because company side is the one side with the arrow. Okay. Last one, customer can buy more than one item.
Yes,
Possible.
ma'am. Many to many.
Yes,
Many.
many
Yes,
to
sir.
many. So B and D are correct here. This type of question is very common. Okay. From your ER diagram, these two types of questions might come. This one and the other one we did minimum number of tables. Okay. So what I need to check is that natural join thing that you are talking about, that it
If you
can work.
allow me, I can show my screen and
Yeah, well, just one second. Okay, so that's the end of the PDF, everyone. If you want, I can share this with you on Discord.
Yes, okay. This is recorded. Lecture is recorded. Yes.
Yeah, everything is recorded. It's on YouTube. Okay, but I can still share the PDF if you want it. You can
Yes,
ask
yes,
me.
ma'am.
Yes, ma'am. Please.
Yes.
Okay, so just practicing these questions. I discuss this every time because this is basically covering every concept that we have learned. Okay, in the first 4 weeks, this is good enough. But also go through all the PYQs that you can find and do the graded assignments one more time. Okay, that should be enough for quiz one. Okay, if you don't have any doubts, you can leave. There is another session tomorrow, so join that one. That is the doubt clearing session also.
Ma'am, at what time is the
Same 6 to
is
8.
okay, ma'am.
Okay, so
Ma'am, where will you be sharing this
on
PDF?
Discourse, I'll
All right.
share.
Thank you.
Yeah. So yeah, all the best for your
Tomorrow's
exam.
DPMS lecture is from 3 to 5.
Tomorrow is from 3 to 5. I was
Yes.
told it was from 6 to 8.
Ma'am, it is TA session.
Wait, let me check the calendar once. 1 second. Hold. No, that is TA session from 3 to 5. Instructor session is from 6 to 8 only.
Excuse me, ma'am.
I think. Wait, let me check once. It is not
on
there in the
calendar.
calendar. Yeah, it's not
Yeah, it's
showing.
showing on 25th of October, 9 to 11, the usual ones.
On
When do you?
Saturday,
Acha, tell
on
me one thing.
Saturday
When
it's
do you have
9
your
to 11.
quiz one exam? Is it on Saturday or on Sunday?
Sunday,
Sunday.
ma'am.
Sunday you have. No, then it will be on Saturday only because for
On
foundation
Saturday
courses,
9 to 11.
Saturday 9 to 11 as per usual. That will only happen because I thought this was on Saturday your quiz one, but for diploma it's on Sunday, right? So you'll have as usual on Saturday only. Okay, yeah. So that thing you can now share. Okay, I will stop sharing my screen. You can share the discourse post. 1 second.
Ma'am, sorry for interrupting.
Hmm.
Uh, I know you are going to share this PDF in the Discord, but I don't know where can I find this.
See, just go to my profile, okay, or you can go to the DBMS course itself on discourse.
Yes, ma'am. I'll navigate to the DBMS course site, but I don't know
Hmm.
where to find this resources.
No, it will come under all of the posts that are there. You can see the posts, right, under
Uh,
DBMS.
if you don't mind, can you please instruct?
I'll show you once how to
Yeah,
check discourse. Wait.
yeah. Thank you.
Okay, visible.
Yes, ma'am.
Okay, this is. Wait, it's taking some time to load. It shouldn't take this long. I think I have too many tabs open. Yeah, okay. This is discourse for DBMS, right? Here, if you go, you should see a page like this.
Yes, ma'am. I'm in the same page.
Yeah, so these are each of the queries or posts, right? So here now, when I post it, it will come after these pinned posts. Or if someone posts something after me, it will also be updated. So I'll try to pin that post so you
Okay.
can find it at the top. Or if you're not able to find it, just go to my discourse ID and check my profile under all the posts you can find. Okay, my discourse ID is Manideepa 2001.
Okay, ma'am.
Okay. Mm.
I will also able to find the previous and the sessions happened before.
On YouTube, you can find all of the sessions under playlist we
I
have
mean, the
divided.
PDFs are also in the sessions you conducted. You
No,
Just
no, we don't usually share PDFs. Okay.
okay.
I share for some sessions, but it is not normal. I mean, not every session you will get PDF.
Okay, ma'am. Thank
Okay,
you.
but if you go to my profile, you can find all the PDFs that I have shared till now on Discourse.
Okay, ma'am.
Yeah.
Thank you.
Yeah, okay, I'll stop now. You can share.
Yeah.
Yeah, rest of you, if you don't have a doubt, you can leave. All the best for your exams.
Yes, ma'am. So this was the I created a table. Yeah. So I created a table. I will create a table student one department name K20. Then another.
So you have created student one and you've created department,
Yes,
right?
ma'am.
And in student one, you have.
Have inserted same values like electronics, computer science, electronics, and computer science. And in the second, I have inserted only electronics and computer science in the department one table.
Okay, so
And
this
when
is
I
working in PG admin, right?
yes, ma'am.
But the thing is, see, in PG admin it might work. I don't know. I haven't done it this way, but might not work in all of them, right? I mean, I don't know if it will work for MySQL or Oracle, all of them. But if it is working on PG admin, it's fine. But usually, if you look up the definition of natural join, then it is mentioned that the ID or attribute name should be the same. So there are some differences in PG admin uh, compared to the other compile IDs also. Okay, but let me still confirm this once with Piyush sir also. So then I'll tell you on discourse only. I can tell you if you just remind me once that what you should do in exam.
Okay, ma'am.
Okay.
Thank you.
Yeah. Thank you. All right, everyone. Thanks for joining. Have a good night.
Thank you, ma'am. Thank you, ma'am.